Okay, so my name is Kazan, and this is my submission for the 2019 CampCon project. So, what exactly is my project? Well, I want to take encryption to a new level, one that was unwarranted or wanted, but nonetheless interesting and expandable. So, introducing the QR code. It's a piece of tech that's been around for about 25 years. Looks like this, and it's been used in everyday life. For the user side, it's relatively simple. I mean, you take a laser or phone camera, and by reading the alignment, spacing, and pattern of these dots, a code can be read. Mathematically, it's very complicated, but from a user's perspective, it's pretty easy. But how safe is this? What if you needed to transport data, but did not want anyone to just be able to take the code and read it? Well, you'd be told to get this encrypted, but how exactly would you do this with a QR code? After learning what encryption actually was, I decided to make a new type of symmetric encryption. So, symmetric encryption is a type of encryption where both parties know the key or the code that encrypts your data beforehand. Asymmetric encryption is when only one party knows it before. This makes it safer because symmetric encryption, if both people know it, a middleman could take the key before and now read your data that you don't want anyone else seeing. Asymmetric, only one person starts with it, and using methods like RSA or the Diffie-Hellman, the middleman can never get all the information they need to decrypt your message. However, I wanted to focus on symmetric encryption because reading about quantum computing and how in the future it could actually ellipse asymmetric encryption and break it. However, this is not the case of symmetric encryption. So I came across the idea of using a visual medium, something to cover the QR code, and distort it. So now you can only actually read the QR code when you reverse the distortion. So the way it would work is a program would distort it, you'd print it out, and you could only then read it when you put the film, I'm going to call it, over the QR code, allowing your QR code reader to actually access it. Now, this is kind of theoretical, but I am going to try and make a quick demo of how this could actually work, get my feet wet a little bit on the project. All right, so this is the project. You can go here and type in a message like hello, and you can hit generate QR code. Now that you have the QR code, you can choose what type of film you want or medium that decrypts it, and then you can distort, and now it distorts it. So the takeaway from this is that once this is sorted, now you can send it to someone, and if they don't have the correct film, they won't be able to view it. Now, real talk here, this doesn't actually really encrypt it completely. Your phone can probably still pick this up. This was more of a proof of concept because it proved pretty difficult to try to find some film that I can computationally model, and for especially for cheap, and just in general. So this is more of a proof of concept to show that this could work if you have the computational model of a certain film that you can buy, and multiple of that. So, and furthermore, this is a little bit overkill for encryption. RSA encryption works wonders and still is way more safer than this. But in the future, when Shor's law and quantum computing becomes a problem, asymmetric encryption could become compromised, which in this case, symmetric encryption might become more important. So this could have the potential to, or at least something similar, could become more prevalent in the future. Overall, I'd just like to say thank you, Khan Academy, for this opportunity to participate in this project. Inquiry like this is always useful in the STEM field, and I'm happy that I could go through this process of brainstorming to presenting, and I think that it really helps. So thank you for all the years of teaching and making this project.